All right, I think the time has come to start lesson 10 dot or dash 4. 10-4 is on expected value. Expected value is basically an average, I guess is a good way to put it. So think of it like this. I'll kind of explain what it is with an example. If I rolled two dice a million times, right? Maybe I simulated that because that would take a while. But if I did that a million times, what would be the average roll? Okay. So you can kind of think, well, what would, if I took up all those rolls, sometimes you're going to get twos, sometimes you're going to get 12s. There goes the dog. He has to drink as soon as I start videos. Anyways, so here is an example. These are all the values that you're going to roll, right, on a two dice, 2 through 12. And here's the probability for each. I think you know that. Would you stop drinking? Anyways, sevens are the most common. Where's my mouse? There it is, right? So that's a probability. There's six different ways you can get a 7. And 2s and 12s are obviously the most unlikely to roll, but you can get them. So on average, if you did this, millions and millions of times, you're going to average out to probably a 7, right? The 2s and 12s are going to balance out. 3 and 11 is going to balance out. 4 and 10 are going to balance out, and your average would be a 7. Here is the formula for expected value. You can write that down if you want, or just wait till the next thing. Again, this one's not too difficult. That's why I'm not going to spend a ton of time on it, because if you think of it, it's kind of like this normal curve, right? It's perfectly symmetric. And when they're perfectly symmetric like that, if I graph these probabilities, right, you can say, well, what's going to be right in the middle? What would be the average value? And that's going to be your 7. Now, when you get to something like this might be a little bit more challenging. So Boris is visiting his grandfather. He gets to take one bill from his grandfather's wallet. This time he peeks, dirty cheater. But he peeks, he sees 2 1s, 3 5s, 2 10s, and 1 20. So if we were at school, I would ask you, okay, let's say we did this, millions of times. What would be the average value? I have to realize that the average does not have to be a 1, 5, 10, or 20, right? It's an average. You're going to add them all up, divide by how many there are. So he might average, what does he got? 2 1s, 3 5s, 2 10s, and a 20. I don't know. He might average around $5, maybe $5.50. I don't know. We'll do it here in a second. But basically, what would the average value that he gets be? So how do you do that? First off, you have to write out all the possibilities that he can get. So there were $1 bills, there were $5 bills, there were $10 bills, and $20 bills. Okay? So I always recommend when you're doing expected value, make a table. So I kind of started out the table for you. Top row will always be what values are possible. Okay, if I go back to the slide, you could get a 1, 5, 10, or 20. We'll use these other numbers to get the probabilities, because in the second row, you're going to get your probability of each. So I kind of got to flip back and forth here. That might be annoying, but so be it. There are 2, 3, 4, 5, 6, 7, 8 bills total, and 2 1s. That's going to be 2 out of 8, right? Or 1/4 if you like to simplify. 3 out of 8, 2 out of 8, and 1 out of 8. So those are the numbers you're going to put in the next line. All right, here's your 25% chance, 3 8s, 2 8s, and 1 8. Now, this third line, they already did it for you, but what you're going to do is you're going to take the value and multiply it by its probability. So 1 times 0.25, 0.25. 5 times 0.375 is this. 10 times that is that. 20 times that is that. And then your expected value, the average value, will be the sum of all those, which in this case is about $7.12 or 13 cents. Okay, this will be on the test, but if you make this table, it should not be too difficult. Make a table. What values can you get? Next line is the probabilities of each of those. Multiply them together. These are all the products down here. Kind of wrote over here. Value times the probability. Add them all up. 7.125. This is one of those things that I would actually take out a notebook, perish the thought, write down a few notes. Okay, here's the step 1, step 2, step 3, step 4, add them all up. And just have that handy. So when you're taking the test and you get this problem, you don't got to go looking through the book and looking through everything. Oh man, it's not, the book is, written in German or something. Right, you'll have nice notes written, hopefully in good King's English. Yeah. All right, well, that didn't go very well, so I will try it again. Well, let's look at another example here. And there we go. This seems to be working better. I had to abort the last time because of technology being garbage. But anyways, let's look at this problem. Excuse me. Suppose that you enter a contest and promises award the following prizes. First prize is 10 grand, second prize is, third prize is, fourth prize is. And obviously with 50,000 people in the contest, most people will not win a prize. So let's look at this. Here are the values that you can win, right? You can win $10,000, you can win 1,000, 120, and of course, a lot of people are going to be winning $0, right? That is a value that we have to think about. So what's the probability for first prize? I would say 1 out of 10,000. Nope. 1 out of 50,000, right? There's 50,000 people. Oh, I'm grateful I didn't keep going like that. I need you guys to check my work, man. 50 second prizes, so that would be a 50 out of 50,000. I'm actually not going to simplify this one, and I'll show you why here in a second. What do we have here? 100, and the next one is going to be 1,000. Again, I'm just kind of taking a shortcut here because I don't want to take too much time. And the last one, how many zeros will there be? Well, it's going to be 50,000 minus these. So 50,000, 49,000, 48,900, 48,850, 48,849. Did I do that right? I hope so. 48,849, is that what I said? See, if I had you guys, I'd just tell you to do this in your calculator and tell me the answer. Let's see here. So if I add 1, that's 50. If I add 50, that's 900. 100 would be 1,000. Yeah, that's good. All right. Again, those are all out of 50,000. Please write. So to continue this, and again, I'll let you do this on your own because I don't want to take too much time, but multiply this 10,000 times that. That's going to be 10,000 over 50,000. This would be 1,000 times 50 would be 50,000. 100 times 100 is 10,000. Again, over the 50,000. And 20 times this would be 20,000 over 50,000. And this is just going to be 0. I'll do that one for you. And then, of course, you're going to add those all up and get your final answer. And I'm going to do that a second, and I will see what I get. But I need my calculator. All right, so you're going to win, on average, $1.80. Your expected value is $1.80. So despite these massive prizes, because there's so many people, your expected value is really not that great. By the way, I simplify these fractions if you're wondering how I got those numbers. So you got to realize most of these raffles, they're going to charge you like, you'd say, well, how are they going to make money? Well, usually they charge you like $5 for a ticket. So if you're making $5 a ticket, or if they're charging $5 a ticket, right, your expected value drops to negative 3.2. On average, you're going to lose $3.20, right? So raffles are usually a loss, but they're also usually for like a cause, like a charity or something. Point is, not getting into all that. Point is, can you find the expected value? And hopefully with this, you can. It's a little messy. Hopefully you can read that. And that's expected value at the end.